Right, okay, now. Just quite nice. Right. Okay, the constant interval.
What should we dressed up as? Rapunzel?
The constant interval goes between. The constant interval goes between 4633 and 5839. What is the average sales? What is the average sales? I've got a constant interval which goes between 4633 and 5839. How would you find the average sales?
Just the midpoint.
Just the midpoint.
Yeah.
Yeah.
Well,
Exactly. Yeah. Because it's plus and minus the same values. It's just the mid. So the mid. If you're ever given the constant interval, want to work out what the mean is, just take the midpoint. Right. So the mean's going to be 4.
I've done the last one.
3 plus 5, 8, 3, 9 over 2 times what? 5, 5, 2, 9.
251. Sorry, 251. What am I talking about?
Yeah. Okay. 5, 2, 5, 1. Do you agree?
Yeah.
Right. So the constant of this interval. So what we've got then is standard deviation 900. So that constant will be worked out. So the 5839, for example, will be worked out by 5251 plus the appropriate Z value times the standard deviation 900 over root n. It's a 9-month period over root 9. Okay, so we can get the Z value. Too lazy, so I'm going to go solve it. 5, very lazy, 5, 8, 3, 9.
That's
equals 5, 2, 5, 1 plus x times 900 over root 9. Very trivial actually. Root 9. See that. That gets me
I think he has
value
ADHD.
1.31.
I think he has ADHD for sure.
Why don't you ask?
31.
Huh? No, I was talking with him about it at Econ.
So he does.
And he was like, yeah, totally.
Oh,
No, he went into detail. He was like, oh, my leg was not. I was like, you definitely
Now,
have
what
it.
you're going to do is work out what that Z value corresponds in the probability. So P Z is greater than 1.3160.
Just the leg. I just feel so bad.
You
I'm
work
like,
that
you
out,
had a
so
good
you
one.
go.
Start your tour.
thank you.
Oh, you just do that again. Okay.
It's just, I'm loving it.
Now, I'm going to go into normal. I'm going to select the Greystone option.
Same, actually. I love that.
He's updated his calculator.
It should be, you should have
A year 10 class, but
2, 8. Execute that. And we've got 0.09. So that value there is. Isn't it? Go central. Putting in.
Put up the video and then maybe we'll know what it is. We're just making noises.
It really upsets me that I'm the only person who's seen that.
show us then.
3, 1.
I don't want that.
Yeah, what I'm doing here is you can use tails, you can use central as well. So what the quick way of doing is to go distribution out. So the confidence level's a bit in the middle there. It's 80,
Is it 5.8?
81. So Z. I can actually do it this way. I can say
Why do you have some smile?
minus 1.316 is less than Z is less than 1.316.
Let's go, Miguel.
Gives me 81
Happy to say you're looking at me.
for some reason.
That's scary.
No, it's not. I'm looking at you.
8118. So do
You're
it that
looking at
way.
me
Put
facing
in the two boundaries for Z value. So what's that Z value?
Because I was looking at you.
It
And
should
you
be plus or
looking.
minus that in the area in the middle. I think you can do that in standard mode as
Kill
well.
me, girl. You can kill me.
You can do stats app. You can go distribution, normal, NCD, put your lower bound of minus
Oh, who's she?
1.316.
Oh, oh, yeah, yeah.
065.
I just had the child version of what I look like.
Put your upper bound
Like
of
really bad
It's really accurate.
1.316.
Does it say that?
065.
Like that's a child, and then that's the actor.
And
Just,
it's
they
the
look
same
so
value.
like.
So which way you have in the pen?
What does the 0.8118 represent?
That's the confidence level. So we're doing
Ah,
that,
okay.
the i.e. an 81% confidence
Yeah,
level.
yeah. Okay, cool.
Okay, cool.
Thank you.
Okay. It's like a bizarre confidence level to use. Yeah?
Also, why did you use the 5,839?
Because I could have used, equally could have used the 4663
Okay.
and put minus Z.
Okay.
I used the upper bound values calculated. The 5839 would be kept with a mean plus the appropriate Z value
Yep.
times the standard deviation over root n.
Okay.
Okay. Or the 4663 would have been that minus the Z
81%
value,
girl.
and then given the same answers.
Okay, thank you.
Because Z is
Like
Z is
EG,
1.31 either way. Okay.
So like, for
I just chose
example,
one of them
81%. I don't know why he did.
Right, so that's giving you the sort of things they can do with constant intervals. You can
81%.
play around with
I
it.
did.
If they ask you to calculate, as I suspect they will, calculate a
liar.
straight constant interval, just use the calculator every time.
Yeah.
If they give you unknowns like this, you do need to really use the formula a little bit. Okay, just to be able to solve unknowns. If they give you an unknown Z value or an unknown mean, etc. So that's that. Right, we're 10 minutes now, and I'm going to go back to the constant interval stuff, which is in content 15.2. And we're going to look at. We're going to go through
What is going on?
quickly.
Hey,
Okay,
wake up.
what I want to do actually is just talk a little bit about. Oh, this is really old from stats
I
textbook.
sit next to that.
It's not it's got some quite good notes on it. There's a couple of bits in there that are not strictly you don't think you need to know. But there's we'll get to it. Let's go up here. So
Just finish this.
right.
No way.
So okay, now if you know the population
Oh
variance,
my god.
you can use the normal
I
distribution.
think I'm gonna kill someone. Look at it.
If, as is going to happen in real life, you're not going to know the population variance, you have to make some decisions. Okay?
Are you crazy?
Right?
I can't.
You can use. You're going to
Yeah.
need to know
It
some
wasn't a
estimate
fun.
of the population variance.
That's why it's all like
Okay.
crimped up like that.
Right now, if you've got a large sample, and a rule of thumb is 30 or above.
Damn. Oh,
Okay.
I'm done now.
You can use the
But
normal
look, it's
distribution,
got like a whole thing
and you
in
can
it.
use.
It's really
And you can use, if you've got a large sample, you can use the population variance, the sample variance, as an estimate for the population variance. But strictly speaking,
Have a nice bomb.
you should use that SX value, and I would recommend you use that whatever happens. Okay, unless you're given the population variance, I would use SX on your calculator, not the standard deviation as the estimate of the population variance. Okay, right? If the population is large, the only difference between SX,
Wait,
between the S squared and the standard deviation squared, is that it divides n minus 1 rather than n, i.e. to convert from the standard deviation to the SX, all you do is you times the standard deviation the variance rather by n over n minus 1. Okay, so the only difference is if I go to get some data on this calculator,
go for it.
different data, see if you see what data you've got on this calculator. So the data, let's go calculate here. One set up, this one,
When?
Your times to get, just get some central data, delete that value. And if I just do that, central
Is he
data
even in there? I haven't seen him in there.
fix it. If I calculate that,
He's what?
you've got here, in the package, you've got
Girl, I
these
thought it
two,
crosses over.
No, you'll see what I mean.
you've got these two values, standard
You do like
deviation,
this.
someone not listening? Standard deviation here, and you've got the SX value. Okay? If you don't know the population variance, right, then you should always use SX as the estimate for the population variance. Okay? The link between these two values is fairly simple. All you do to get from the standard deviation here to the SX is you square the standard deviation to get the variance, times by n over n minus 1, and then square root to get back to that. Okay? The link is at the variance level, okay, i.e. this times n over n minus 1 will get you this. Okay? Right? And hence that's what I say about using the n minus 1. Technically, you should always, and I recommend you use the SX button. If n is large, these two values, n is large, n is 114.
Yeah.
You can see they're pretty similar.
If it's
Different.
lower than it's.
They're pretty similar. The lower they are, the more these diverse. Okay? Right? And 30 is kind of the accepted definition of what large is. Okay? But it's not always as clear cut that it's that. It's not always exact science. Okay? It depends on how normal-esque the population distribution is as to how good this fit is. The bigger, if it's bigger than 30, then it's only fine. So generally, a rule of thumb, and it's a rule of thumb, it's not hard and fast rule. But my recommendation is, if in doubt, go with SX over the standard deviation. Okay? Right? Because you'll never get. Technically, it's correct. It says here and here. Technically, you should be using the n minus 1, the SX value, rather than the standard deviation. Okay, so if you're given population parameter, use the SX value for your standard deviation. Calculate your confidence interval that way. That's what the calculator will do as well. But anyway, the calculator will do this for you anyway. Okay, so if you've got some large data, let's have a look. If you've got some large data, you just use the normal distribution as per normal.
I'm gonna watch that. Like the first man.
So,
Okay.
so when you're doing your confidence intervals, if you use beta, that means you know the population values, but if you use F, that means you don't know it. Is that the idea?
Yeah.
Okay, thank you.
Right. Okay. Let's have a look at this here. So,
Has this got like,
so if you've got a large value,
You don't want to
you can
hold
just
hands.
use the Z distribution.
she's always trying to hold her.
But
I hate it.
yeah, let's go look at what happens
You know?
if you've got a small number. What I'm going to suggest is actually, if you're not sure, if you've got a small sample, let's go on a little bit.
Well, boom. I said if I catch it 5 times, I'll pass my
If you've got a small sample, you can't use the normal distribution anymore. Use what's called a T distribution. And what I'm going to suggest, if you're not sure whether to use a normal distribution or a T distribution, you should use the T distribution every time. Because if n is large, the T distribution and the Z values become the same anyway. So what I'm going to suggest you use is, if you're not sure, go with a T distribution or a Z distribution. I'm just going to look at the T distribution quickly. So we can scroll down here into this old Strapi textbook. It talks about the confidence levels, etc., in the same way that you've done already. And the first it says there is that. Confidence of a large sample, we've done some of that. Talk about large samples and say you can use normal distribution. But then it goes on here. Keep going. Sorry.
You can't hide him.
Great. Okay, now it talks about the T. It's called the student's T distribution. I think because